Example 3, Fluid Mechanics. Chapter 5. Consider the equation P equals to the relation of Q, T, omega, rho, and viscosity, which P power input, volume flow, impeller diameter, D, rotational rate, omega, and the density rho, and mu viscosity. In this case, we can write the dimension for various parameters. We have n equals to parameters 1, 2, 3, 4, 5, 6. So the dimension for P is power FLT minus 1. The list of dimensions are available in the table in the reference. Q, L3, T minus 1, D, L, omega 1 on second, which is T minus 1, rho, L, we should write as a function of F, because F T 2L minus 4, and for mu we are going to write T minus 2. Our system is contain F, L, and T subdimension parameters are 6 dimensions are F, L, and T. So we are going to choose the repeating variables. In this case, we can obtain various repeating variables. It depends on our experimental output. For example, we can choose rho, omega, and D. Rho, for example, omega and Q, and we can obtain select also these parameters. For example, rho can add all the dimensions in rho, cannot cover the other dimensions in two other parameters, rho with omega and D, rho with Q and L. We can also obtain mu, omega, and D. For example, mu, omega, and Q, F, omega, and D, F, omega, and Q. Anyway, we can write our repeating variable, we choose the first one. It depends on the experimental output and input data, or in the scaling down limitation, or scaling down availability and geometric limitation, we can choose the appropriate repeating variable rho, omega, and d. So we can choose n, a curve which is equals to the parameter 6 minus the 3 repeating variables is 3. We have 3 group of pi. The first group, we can write this relation. For example, d omega and rho pi 1, we can obtain pi 1 omega rho d a b c multiplied to the one other parameters. At first we can choose, for example, power P should be equals to the dimension, which are L, T, and omega A equals B, right? F T to L minus 4 B L C multiply the power dimensions so we can have the relation for a force. Let me write the relation again here. We have T minus 4 omega. For rho, we have F T to L minus 4 minus 4 B L C and F L T minus 1. So we have a relation for force. For length, we have the relation for this one, C and 1. For the other case, time, minus A plus 2B so we can obtain A equals to minus 3B minus 1 and C minus 5. The other pi group is pi 1 A minus 3 omega minus 3 rho minus B minus 1 and L minus 5 multiply to P. This is the pi group. This we can write as the P power on the omega 3 rho L 5. Power coefficient of a pump. Cp P omega 3 rho L 5 power coefficient of pump. The next pi group can be omega A rho B L C multiplied to, for example, two other parameters we had mu and q. We obtain mu, we can select -1 power to have a better relation and calculation, or we cannot, and plus, we choose plus to make a calculation to and test the result. For omega, for rho, T to L minus 4 B plus LC, and F0, L0, T0. The relation can be obtained at minus A for T for force at first, right? Force F E plus equals to 0 for time minus A plus 2B minus 1 for length. It is minus 4B C plus 3 equals to 0. We can obtain the for mu. Excuse me, we have F also. Let me change the answer for at first Q. In this case, we can obtain the powers A equals to -1, B equals to 0, and C equals to -3 divided power by 2 Q omega -1 and 0 L -3. So Q of omega L3, which is CQ, called as the flow coefficient of a pump. Pi 3 equals to the relation T minus 1 A FT2 L minus 4 B L C FT L minus 2. FT L minus 2 equals to F for force. We have B plus 1 for time minus A plus 2B, and for length equals to the minus 4B plus C plus minus 2. We can calculate and C pi 3 mu on omega rho and d2 d square. This is the can be sort of Reynolds numbers. The ordinal relation between 6 variables is now reduced to the 3-dimensionless group, which are P on rho omega 3 d5, a function of two other pi's, d3 and the recently mu on rho omega d2.